Hello, my name is Angelos Lagoudakis, and I'm a PhD student in economics, a third year PhD student. And my research focused on food and health economics and consumer and producer behavior. I employ statistical and mathematical and econometric tools to answer questions relevant to applied economists, data analysts, and policymakers. And by that, I work in two ways. First, I invite people to a lab session to conduct an economic experiment where I ask them questions about their consumption habits, and I try to elicit to get information on why they stop what they do, what influence their decision making, and what are the outcomes, the health outcomes in terms of nutrition. Um, the second way I utilize research is I'm conducting research is by utilizing scanner data, grocery store data that come directly from chains of grocery store I collaborate with, and I analyze again the shopping patterns, and I'm trying to explore what is the effect of government policies on consumer behavior, and in turn what is the nutrition outcomes, the health outcomes of these shopping patterns. Finally, I'm really interested in engaging with producers, with a wide audience when it comes to supply chains, and discuss issues and effects of policy on value chains, vertical integration of supply chains, and day-to-day issues to the stakeholders.
Hello, my name is Matt Kavanaugh, and I am a first year graduate student here at Iowa State studying agriculture meteorology in the Department of Agronomy. Today, I would like to talk a little bit about my research in less than 3 minutes. So, essentially, the main goal of my research is to better understand and analyze the ways in which changes in land cover, soil roughness, and crop water impact the signals that are received by soil moisture satellites over the course of the year. Soil moisture satellites are an extremely valuable tool for farmers and other land managers as they can tell how much soil moisture is present or at least have a given estimate of soil moisture over a broad area with a very decent spatial resolution. So they can see how much soil moisture there is in a relatively localized area. In order to better improve this algorithm that the soil moisture satellites use, it is very important to understand how changes in the land use and land cover vary over the course of the year as these satellites work based on microwave signals that are emitted from the Earth, and these can be affected by various objects and different soil textures that occur on the Earth's surface. Over the course of the summer, I worked with my research group to take various samples of corn in the field in which we would measure various corn plants over the course of the summer to see how much water they contained. We would do this approximately every 1 to 2 weeks to see how much crop water there was contained within the corn at our research field. We would measure the wet samples containing the total mass of water within the plant, and then we would put them in dryers for up to a week and a half and then measure the mass after they are dried out. Additionally, over the summer, I worked with sap flow sensors, which emit a heat pulse and then record the temperature upstream and downstream of the pulse to determine how quickly the heat is dispersing throughout the plant. This provides a rough estimate of how quickly sap is moving throughout the stem and how much water the plant is uptaking. Understanding that information will be very important to improving the algorithm as sap flow correlates very nicely with the amount of crop water. So we can see how much the water in crops is impacting soil moisture retrievals. In the future, I will be testing various models to understand how various changes in crop water and soil texture will be impacting soil moisture readings over the course of the year, and using this to help improve that algorithm. Thank you.
Hi everyone, my name is Imano Padamanti, a first year PhD student in the Department of Civil Construction and Environmental Engineering. As urbanization and climate change is affecting the available water sources, it is expedient that researchers come up with alternative solutions to this issue. My research focuses on accelerating technical and community readiness for water reuse in small systems and in small communities in the United States of America. The research involves 4 communities, and although the communities have not yet been selected, the research group is trying to come up with an algorithm for the selection and making sure that these communities do not have similar characteristics. My work is to focus on the quantification of the available water, that is, rainwater, municipal wastewater, stormwater, agricultural runoff, and return flow, whilst incorporating the impact of climate change. The second aspect of the research is to come up with cost curves to estimate the cost and benefit associated with these sources. The results produced from this research will provide decision supporting tools which will be integrated into institutional and regulatory decision making. And one important aspect of this research is to bridge the knowledge gap when it comes to water reuse, since most people have a perception on water reuse. I'm excited about the research and I can't wait to continue to come up with concrete evidence that could be used in these decision making tools. Thank you.
Unprecedented climate change is impacting every sector of society and changing the way we live. Picking up the pace of emission reduction at the subnational level is central to achieving the national target in the US. End use electrification contributes to reducing greenhouse gas emission and thus is an effective way to mitigate climate change. Economy wide, electrification will spike the demand for electricity, which largely depends on factors such as population, economics, policy, and regulations. Past research has projected US electricity demand under different assumptions, yet how each state responds to climate change mitigation under various socioeconomic development is unclear. Therefore, our research aims to advance our understanding of the interplay between top down climate change mitigation and socioeconomic development in affecting the US electric power sector at the state level. We use the Global Change Analysis model, the US version. It's an integrated assessment model that assesses the dynamics of the coupled human Earth system and its response to global changes. A state level future electric power demand was projected under 4 future scenarios. We are analyzing the relative impact of climate change mitigation and socioeconomic development on electricity demand for each state and have identified spatial dissimilarity closely tied to structure of the state's economy. Furthermore, we will run the power grid management system for the Texas grid to predict next day electricity market prices and analyze the relative impact of mitigation and population dynamics on price fluctuations. Our primary results suggest that the electric power sector will respond differently to top down climate change mitigation at the state level. Both mitigation and population dynamics will affect how the electric grid would respond. This robust state-level assessment will provide useful insights for future electric power system planning that meets demand, mitigation, and economic objectives.
Hello everyone, my name is Gabby Myers. I'm a PhD student in Ag and Biosystems Engineering. My major professors are Raj Raman and Dan Anderson, and my other committee members are Amy Kalita, Ken Moore, and Bobby Martins. Today I'm going to be talking about my dissertation topic, which is evaluating an integrated perennial ground cover and anaerobic digestion system. When you think of Iowa, you might think of the highly productive agricultural systems we have in place here. Iowa's farmers produce more corn than any other state and more than most other countries. Iowa is also the leading hog producer in the country, with far more pigs inhabiting the state than people. These systems provide the world with food, feed, and fuel, but they are not without their challenges. In a traditional corn and soybean rotation, the field is left bare for a portion of the year. The lack of plant life and root mass leaves the soil vulnerable to erosion and leads to the export of nutrients via runoff and leaching, reducing water quality in Iowa and far beyond. The large number of pigs we have in the state produce a large volume of manure. Properly handling this manure is a challenge for farmers who want to minimize air and water pollution due to the manure, while also maximizing the recovery of the valuable nutrients it contains. One way farmers deal with manure is through anaerobic digestion. Anaerobic digestion is the process by which microbes break down organic material to produce biogas, which contains mostly methane and carbon dioxide. Manure can be used as a feedstock for anaerobic digestion, and the captured biogas can then be upgraded to renewable natural gas quality and utilized as a transportation fuel. In addition to manure, using corn stover as a feedstock in anaerobic digestion may increase the digester's productivity. One proposed solution to the bare soil problem is perennial ground cover, or PGC systems. A PGC system provides year-round ground cover in agricultural fields. These systems may reduce soil erosion and nutrient export, as well as possibly allow for increased corn stover removal from fields without the negative soil health drawbacks. The PGC systems being developed are also less complex to manage and less expensive than conventional cover crop systems. In my research, we are looking at a combined system of anaerobic digestion and perennial ground cover. Anaerobic digestion is most often deployed at dairy farms, and the biogas is utilized to create electricity, so less is known about the economics of a swine manure corn stover system that upgrades biogas to renewable natural gas quality. With the perennial ground cover system, the water quality impacts have yet to be fully validated. I have three main research objectives. The first is to validate the water quality impacts of the PGC system through field trials in Nashua. The second is to explore the economics of the swine manure and corn stover co-digestion system. And the third is to evaluate the environmental impacts of that same system. Long term, I hope to provide concrete information to farmers and other stakeholders on the environmental and economic impacts of perennial ground cover adoption. And secondly, I hope to provide an economic model that could be utilized by livestock farmers to determine the best course for anaerobic digester use.